All right, so we're in chapter 5 on accumulating change, limits of sums and the definite integral. So this is section 5.2 on the limits of sums and the definite integral. So as we stated in the last section, this section actually covers rates of change data that is not simple and we must be modeled by a continuous function. So a series of rectangles is going to be used to approximate the region between the function graph and our input axis. And we're going to do that in 3 different ways. The first way is using the left rectangle approximations. So these rectangles are shown below are referred to as left rectangles because the height of each rectangle is the output value of the function c that corresponds to the left endpoint of the base of the rectangle. Now the area of each of these left rectangles represents an estimate for the number of customers entering the store during that 1 hour interval. So each one of these hours, we're breaking the rectangles into 1 hour intervals down here, as you can see. And so then we sum all those estimates up for each of those 8 hours, and that gives us an estimate for the total number of customers entering the store during the hours of sale. Now, the table summarizes the calculations of the areas of each of the left rectangular regions, as well as the left rectangle approximation of the area of the region under the curve. And so what we see with the left rectangle approximation is the left part actually touches the curve. So it always is going to be on the curve. Now what happens to the right, it goes 1 unit, whatever our rectangle size is, whether it's 1, a half, a quarter, or whatever it is, it goes over that far and then down. And then we can calculate the area of that rectangle. It's going to be 1 times whatever this height is. So in this case, 240. And so 1 times 240 is going to give us 240 for the area of that rectangle. And that goes on this line 1. So our left endpoint, well, that's going to be when it hits the graph at 0. Then we go down. So the left endpoint is 0. Our height, well, that's, we said, was 240 over here. And so C of 0 is 240. And then what is that going to be for area? Well, it's going to be the width, which is 1, times the height, which is 240. So it gives us 240. And so then we go to the next one. So at 1, we go up here, we touch the curve, we draw our 1 unit across and down. That unit looks to be about at 264, it says. So we take 264 times 1, we get the area of that rectangle is 264 customers. Because again, it's customers per hour times number of hours. So that gives us the number of customers. And we do that for each one of these. And as you can see, some places it really kind of gives us this huge area out here. Sometimes we kind of underestimate. So, we kind of have both parts here, over and underestimating as we go along. Now, some of them, as it gets closer down here, that looks a little bit better. That top one here, that looks really good. It's not much of an overestimate at all. And so what we do is we go do that for all of these rectangles, 0 through 7. So there's 8 of them. And then we get all of these areas and we add them together. And when we add them together, we say, well, there's approximately 1,500 and 1,570 customers that are under this curve. So if we actually did the under the curve, we're saying based on the left rectangle approximation, that's going to be 1,570 customers. Now, this 1,570 customers was gained by something called sigma notation. So what we were doing, we're taking all of those areas, which we represent as the xm plus 1, all the way to xn. Those are input values for a function f, and m and n are integers where m has to be less than n. So m is less than the n. And we're just taking the sum of them. So again, we just took all those things together and added them. The 240 plus 264 plus 260 and on and on. And so we're just adding each of those together. And instead of writing it out longhand like that, what we're going to do is we're going to use this format here. And we're going to use the Greek capital letter sigma. And we're going to say sigma, the sum of all the f of xi's from I is equal to m all the way to I is equal to n. So we're going from m to n. Okay. Now, this summing of the rectangles to approximate the area under a curve is attributed to Riemann, and the sum of I equals 1 to n, f of x sub I times delta x is called the Riemann sum. So it's a special type of sum. And that's what we're doing here in our case of our rectangles, because we're going to take, and we're taking each of the, in this case, heights times our widths, and we're taking the sum of all those. And again, our delta x is our width, and the f of xi, that's going to be our height. We're taking the sum of those, and that ends up being 1,570 customers. So what we have to do is it's nice to look at it this way because, we have a short little notation, we get a final answer and we have it. But to get all of those, we actually have to kind of do a table and find out all the pieces. So what's going to happen eventually is, you're going to end up doing, 7 or 8 and then go to 20 and then 40 and so on. So sometimes it's going to get very tedious to get all of the sum of these to actually find them. All right, so now we would left. Now we're going to do right rectangle approximations. So this time the rectangle is between the horizontal axis and the graph of the function f, with the height defined by the output value of f corresponding to the right endpoint of the base, touching that touching that graph. So what happens here is, remember last time we would have gone all the way up to this point and then we would have drawn out our thing for the left, but now we're doing the right. So we're going up here and then we're drawing something to the left. Okay, and so this is the right endpoint, whereas the other one, if we did it, it would be the left endpoint starting here and going down. Okay, and so then we go to the next one, go over and come over to our graph, and we find all of those areas. Okay, now unfortunately, this one also has some negative areas too, so we actually have to do 2 pieces for this one. So we have the first part we have to do to get that, and so we're going to go from 0 to 1, and then we're going to multiply that times, in this case, they say it's 1.09, so we multiply those together. And we're going by 2s this time. We're not going by 1s, actually. 2, 4, 6, 8, 10, and then 12, 14, 16, 18, 20, and then 22, 24, 26, 28, and then 30. Okay, now notice at 30, guess what? It starts here and goes this way, and there's not going to be any area here. So sometimes you have to think about that because you're not going to actually have an area. So again, we're just taking and adding all those pieces together. So we take 2 times the 1.09, and then we take and multiply the 2 times 0.7. And it must be a rounding error here because they don't put all the decimals, but then they have this. And so they continue on. And then this time they're showing us, instead of just saying that we added some of them together and got that, we're showing it in the sum notation here. So we're taking the sum of I from 1 to 10, from 1 to 10, there's 10 of them here, of the heights times our how far each of these is. This is 2 units this time, and so basically this times 2 gives us this, and we're taking the sum of all of those, and we get 5.97 micrograms per mil, because it's going to be micrograms per mil per day times days, so we just get the micrograms per mil. And so that's the positive part. Now we have to do the negative. So we're going to again do going down to the curve, hit the right point, go over, go down, get another right point, go over, and get another one. And then this one, remember I said that was 0 basically. They're calling it negative 0.01, but it's almost 0 because you can't even see anything here. So, I would almost say that would be a 0. But in any case, you're going to do and take the sum of those. Again, this time we're going from 11 to 15 because that's where we are, what number we are. We did 10 rectangles here. Now we're doing 11 through 15 here. And so we add those up and we get a negative 4.54 micrograms per mil. Now to get the total net area for the upper and the lower, again, we're going to get the area from here and all this here. We add those two together, or basically we subtract them, and we get the 1.44 micrograms per milliliter is what's going to be in our body if our height is such and such, and so on. Okay, so that's how we do the right ones. Okay, now what happened was we noticed that with the left one, we really over approximated our area under the curve. And then our right one, we kind of really underestimated the approximation under the curve. And that's really what happens is the left ones are usually over, the right ones are usually under. And we can see that in this example here, where we're looking at f of x is equal to the square root of 4 minus x squared. And we're using only 4 rectangles here. So that's the key point. We're only using 4. So when we use 4, again, we're going from the left one here, and we get, all that overestimate. And on the right one, we start here and we go left, and then we go here left, and then we go here left. And again, here left, that's going to be 0 basically. And so we add all those 3 together, we get 2.496. We add all those 4 there together, we get 3.496. And how does that compare to the actual value? Well, this one overestimated because the actual value is 3.141593074, and 3.4, well, overestimated it by about 0.35. This one, 0.2496, we're underestimating it by a lot more than we actually overestimated that one. So with small number of rectangles, the overestimation and underestimation is going to be a lot larger. All right, so let's pause there and we'll come back for some more.